Yeah, hello. 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 Yeah, hello. Hello. Hello, can you hear me? Hello. Hello. Okay. Okay. Yeah, good evening. Welcome to this last session on protection planning control. So, so today I will be discussing some of the concept related to transportation, which is a part of linear programming. So I'll be discussing some of the methods. So what exactly a transportation problem is, and then discuss some of the models related to it. So this was a simple concept. I think you'll get it from by the end of this class. Yeah. So let us start. So so let me start with a basic example to understand what is the need for this transportation. So suppose we have a supply. So today's concept is, you know, transportation. So the first concept will be, if suppose, so this transportation mainly happens between factory to warehouse. So warehouse is nothing but the we can say near to the distribution. You can say something like that. So this is the transportation happen because the factories are located somewhere else, and the consumers at the warehouses in this case will be located somewhere. So the main goal of this transportation is how to minimize this transportation cost between this factory and warehouse. For example, so what is the need? So if we already know the cost, we already know the transportation methods, but then what is the need for this transportation problem is, for suppose we have supply and we have demand. Okay, so we have 80, for example, 120 and 50. So this is the supply. The supply is like the fixed quantity from the factory side. So it depends on the mm, the manufacturing capacity of the plant. Then we have 65 demand. Means this is for different warehouses, and this is, say, this is factory 1, factory 2, factory 3, and this is warehouse 1, warehouse 2, warehouse 3, and warehouse 4. So we suppose we have 4 warehouses. Then this is the demand. So we always ensure that the supply is equal to demand. Okay, so now that I can get so many transportation models in this case. For example, this F1 can transport to W1 directly, W2, W3, or W4. Similarly, for the others, uh, for others as well, other factories as well. So now we define a term. Now we define a term that is CIJ. So which is known as the unit cost of transportation from ith factory to jth demand center, in this case warehouse. Okay, so this we have several. So that this is one, this is one, this is one, this is two, this is 1 3, and this is 1 4. So one, this I indicates the factory and J indicates the warehouse or wherever the supply we have. Okay, so now the main goal is, our main goal is to minimize this transportation cost. So this is the whole motto for this transportation problems. Okay, so generally, what is the basic structure? Will is, so we'll on the left side we have from, on the top we'll have 2. Okay, so here we'll have F1, F2, F3 in this case. Then here we'll have demand, so we write as D1, D2, D3. Okay, so now we can fill. Okay, this is from factory of 2, this is demand. So now in the bracket, generally in the bracket we write the cost. from certain factory to certain warehouse. Okay, so and then we'll write this up in this column. We'll have demand, and from here we'll have supply, because demand two side will have the demand. So 35 for this whole D1, 85 for this whole D2, and 80 for this whole D3, whereas factories can supply 60, 90 as well as 50. So we will make sure that the supply and demand are equal every time. Okay, so this is the basics introduction to this transportation problem. So we'll have basically different stages in this. So that is, stage one is to find initial solution. This is also called as feasible solution. Then in stage two, so we will have the final solution, also known as optimum. Okay, so now if you see, there are some models for this finding this initial solution as well as for the optimal solution. I will write some of the models here itself. So finding initial solution, we have least cost entry method, LCEM, northwest corner method, Vogel's approximation. Then for finding optimal solution, we have stepping stone method and modified distribution method. Okay, so let us discuss in this session. I'll try to cover all uh, this with one of the solution, the final optimal solution. Let us see how it goes. So let us start with the basic first, uh, you know, first solution. That is this initial solution by least cost entry method. Okay. So the model itself indicates what exactly is it. So we generally allocate. So this allocation happens for the factory and the demand. So we will allocate which factory should supply to which demand based upon the cost of transportation cost. So that should be, so if that cost is least, so we will allocate easily. So that is the basic principle behind this. Let me quickly write the take some example and explain. Suppose we have different factories, for example F1, F2, F3. Similarly, D1, D2, and D3. Okay, so now I will also write how much factories can supply, whereas how much demand we have, actual demand. Better to tablet, so it will be easy for doing the questions. Okay, so now I will write the cost as well. Okay, so now let us start. So this, as I said earlier, least cost entry method. First one is the select the least cost in the cell, that is, which is the least here. We have this 2, so that we can write as C2 3, that is 2. So if we go to this 2 column, then we'll see the supply as well as demand. We have 90 supply, but required is only 980. So what we do, we'll allocate this 80 here, then we'll 10 is the remaining, and we close this. So that is D3 column is closed. Okay. Select the list of supply and demand and cancel. Allocate and cancel. Okay, that is the second step. Then start, repeat this. That's it. That's it. So let us proceed. So this 2 is done. So we'll select the minimum in the next D1 and D2 rows or column. Sorry. So we'll get 2. So this is the first allocation. This is the select second one. So we see 35. So we'll allocate this and we'll directly strike off this D1 column. So then we left with only one column. So we'll directly allocate whatever it is. So we need 15 in this. So we will allocate 15 here, 0. So 50 if we'll get 70. So we'll get 10 here. So we'll get 60. Then we'll get 60 here, 0. Cancel. So this is the the basic method for calculating using this least cost entry method. So the total cost is, we'll just multiply with whatever is there in the. So initially we started with 2 into 80 plus, then we went into 4 into 35 plus 6 into 15 plus 9 into 10 plus 6 into 60. So that gives you value of 840. Okay, so this is the basic method which we can use in least cost entry method. So let us now so I will give one example, one homework problem that you can try by yourself. Just note it down quickly. So we have 3 different factories and 4 different demands. So try to construct, to avoid the confusion, if any. This will be handy in for future reference also. So we have a supply and we have demand. Check if supply is equal to demand and then proceed. Otherwise, you need to add a dummy column or row in order to satisfy that. And do not allocate in that dummy column because it is not actually a physical quantity. Okay, if there is any doubt, you can ask or you can put in the chat. 10. Okay, just try it yourself. So I will give the answer. Total cost using least cost entry method is 1200. Okay, good. Let us move forward. So this is the homework problem you can try. So now I'll solve the same problem using the second method that I discussed. Just a second. Yeah, yeah, that's it. Perfect. So next, the second method, northwest corner method. Okay. So let us see what actually it is. So in this northwest corner method, so it is pretty straightforward. We select the this point. Select the northwest corner cell, and we irrespective of anything, irrespective of the value, we'll just go on allocating. So this will result in a similar solution for anyone. Okay, that's the good thing about this. So let me try to solve this. So now, as I said, so initially we'll go with the this column, that is E11 or 11 column. Sorry for that. Okay, and we'll see whichever is minimum. So 65 is minimum, so we'll just subtract. Okay, and we'll put 25, and in this we need to cancel the row column. Okay, so 4 into 25 plus. So next, let me write the step. Repeat till all achieved in the case. Okay, and it is this usually. Then next is northwest corner is this F2D1. So we'll see 25 is the minimum. 25 will write 0. That's it, and we'll strike off this. Then we'll go to the next immediate, the seventh column, and we'll see 60 60. So we'll get 60 with 0 0, and we'll in this case we'll strike off both since both are achieved. So we are finally we are left with only two, that is 8 and 3. So we'll directly allocate 40 20. Okay. So this is the model in northwest corner method. Okay. So let me write all the values. And you should get 1360 using this northwest corner method. But if you use same method in using least cost entry method, you will get 1200. So basically this is giving you, so I forgot to check this. It is giving the upper bound for the cost estimation. Which part you want to repeat? So this is the one. This is by northwest corner method. So if you calculate this, you are supposed to get 1360. But if you do the same problem using this least cost entry method, you will get 1200. Okay. Okay then. So this is the other method, that is northwest corner method. So let us move to the interesting one, that is the Ogle's approximation, which I will solve the same method and see what exact value it will give for us. So I'll take the same problem and okay. So this method is Ogle's approximation method. Okay. So in this method, basically we calculate penalties, and according to the higher penalty, we allocate the cell. Okay. So the steps are simple. So I will write the steps here. So first cell is sorry. Yeah. Find the penalty values for each row and column by sorry. Yeah. So we'll get this final just a second. Yeah. This is, I think, right here. Sorry. So we'll find the penalty for every column as well as row by just subtracting minimum and next minimum value in column or row. The second one is select the highest penalty and allocate. Repeat step 1 and 2 till all is achieved. That's it. I will explain how to calculate this penalty. So now let's go to this penalty. Okay, so let us see for the first row. So we have 4, 6, 8, 9. So we need to select the minimum and next minimum. That is 4 is the minimum and the next minimum is 6. So we'll get 2. Similarly, for the next one is we have 7 and the next one is 2. So we'll get 5. Similarly, we do for the this third row, that is 6 minus 3, that is 3. Okay. Similarly, for the columns, that is 2, 1, 6, 7, 1, 6 minus 7, 1, 8 minus 8, that is 0 in this case. Okay. Then in this last one, it is 2 minus 3 minus 2, that is 1. Minimum, sorry, here minimum is 8 and next minimum is 10. So it is actually 2, not 0. So this is the calculation of the penalties for the first iteration, I can say. Okay. Then we'll select the maximum penalty, that is this one. And we'll see whichever in this row, we'll select the minimum value. So with 12, 7, 10, 2. So 2 is the minimum value. Then we see we see this the demand as well as supply, whichever is minimum. So here, right. So minimum, so 20. So we'll directly allocate this 20 value here, and we'll subtract that 20 from this demand, that is 85 minus 20, that is 65, and we'll cancel this D4. Okay, since it is completely allocated 20, 20. So now we have only left with D1, D2, D3, and then rest. So again in the second, so this is for the first time penalty. Similarly, you need to repeat for the second time penalty by neglecting this D4 because this is allocated. So now here 4 minus 6, still 2, then 10 minus 7, 3, then 6 minus 8, 2. Then in the columns, 4 minus 6. So column it will not change, right? It will be the same because we are not deleting it. So now we see the biggest is 3 again. Then again we'll see in that row whichever is minimum, that is 12, 7, 10. That 7 is the minimum value. Then we'll see the demand 60 as well as the supply 65. So 0 and then 5, and we'll cancel D2. Okay. Then again we have to see for the next penalty. So this will not change, that is 2, 2. Then we'll see here. So now we have 4 minus 8, that is 4. Then 12 minus 10, that is 2. Then 8 minus 6, that is 2. Okay. Which are is big? That we select, that is 4 is big. And we'll see the minimum in that. That is nothing but 4 is the minimum. And we see the demand 90, 65. So 65. Okay. So we'll get 65 completely to the factory one itself. Then we'll delete this 90. 25, sorry. Yeah. So, and then we'll delete F1 instead of D1 because F1 is completely filled by these supplies itself. So now we delete this one. So if you see, we are left with only, let me actually delete. So we are left with only F2 and F3. Okay. Then we'll do the one more time. So if you see 12 minus 10 is 2, 6 minus 8 is 2. Okay. Then we have to see for the, now these things will not change because the column is separate. We have to see the this demand side. So now if I get 12 minus 6 is 6. Just a second, I'll move these things a bit. Yeah, good. So now, so what I'm saying is, so now we have done for the this thing also. Now we'll calculate the again. So this now rows will not change because row is got deleted. The columns will change. That is 12 minus 6 is 6. Then in this column 10 minus 8 is 2. So 6 is, the bigger penalty. Then accordingly we will allocate. So we'll see in this 12 6, 6 is the minimum. So we have 25. So we'll allocate 25 completely. Okay. Then we will strike off D1. So finally we are left with only one column, that is D3, nothing but 10 and 3 are left. So we will allocate whatever is left, that is 5 we left here and then 35 left here. See, they sum up to 40. So that is how you can also verify whether you are doing the correct value one or not. Whether you are allocating, if there are any mistake, you'll directly will come to know by this. So now you can calculate the total cost as usual. That is 4 into 65. I'm coming from the top. Then I think there is 60 here, plus 7 into 60 plus 10 into 5 plus 20 into 2 plus 6 into 25 plus 8 into 35. If you calculate, you will end up 1200. Okay. So if you see, this Vogel's approximation is like, will give the values similar to this least cost entry method, and this is always preferred for the initial solution. Vogel's approximation always preferred for the initial solution, but this northwest corner method, so whoever does it, they will get the same value. For example, in this Vogel's approximation, suppose we got 5 here, instead of, for example, we get 5 here also. Suppose if someone takes this one, someone takes this one, the value may change. But in northwest corner method, whoever does the problem, everyone should get the same value. So there was one gate problem similar to this northwest corner method also. You can verify. Okay, this is the method for getting initial solution or the feasible solution. Why we are saying this as initial or feasible? We don't know whether it is the optimal solution or not. There might be anything. So now, instead of allocating like this, I can allocate it differently also, because this whatever value 1200, I don't know whether it is the optimum or not. So I have to go and check for this. So for this Vogel's approximation also, I will give one homework problem. You can try.
Sir,
Yes,
sir, if in both the places five is, if we get five highest values, sir,
yes, yes.
then what we should do, sir, means in which we should allocate first, sir.
So it is like a trial and error method. You need to go. You can select anyone,
Yes,
either
sir,
the
means
row or
in both. Yes, sir, but answer will be different, sir, in both the cases.
yes, yes. Answer will be different. So that is why we call this as initial solution.
Oh, yes,
Answer
sir.
will be different. Yeah.
Okay, sir.
Now we try to optimize this initial solution. So we have different methods for optimizing. So now in this session we will discuss this modified distribution method. Okay, modified distribution by using UV methods. So let me start with sorry, I forgot to give. So there is one homework problem I will give. You can try yourself. So these are the cost values. I also gave this similar problem, but you can try with the same problem and see how much you are getting. Okay, do this by this ogles. So you should get 840 in this case. A similar problem we also tried with least as least square least cost entry method. We also try with Vogel's approximation and see what is the difference, what different value we are getting. So now we move to this, uh, this optimal thing. So before that, so there are some conditions that need to be satisfied for optimum solution. There can be any number of feasible solutions as we discussed earlier, but there will be only one unique optimal solution. So the first thing is these allocations should be equal to m plus n minus 1, where m is number of factories, n is demand centers. Okay, so let me see for the previous one. So we have this here, m is equal to 3 and n is equal to 4. So we have total 7, so we should have 6 allocations. So 1, 2, 3, 4, 5 and 6. So this is the test. Initially we have to see that number of allocations should be equal to m plus n minus 1. So then only we can move with this optimal solution. Otherwise we have to make some changes to the initial solution to these allocations, then we need to move to the optimal solution. So that is something called as degeneracy in the solution. So now the second one is the all these allocations should always form an open loop. So what is this open loop? For suppose, just for an example, so suppose we have 3 different factories and 3 different demand centers. Just assume. Then suppose we have allocations like this. Okay. So wherever all the allocations should always form an open loop. So if you try to combine all these allocations, they are forming an open loop. So they're not forming a closed loop here. However you try, you should go only through these allocated cells only and draw only straight lines and see if they're ending in a closed loop or open loop. So I'll give one more example for this closed loop also. So in this you can easily join any some of the and form a closed loop. So this is closed loop that we don't want. They always should form. This is just a condition. Should form an open loop allocations. Okay, we can see in coming problem that I solved. So now the third one is this solution should. So this is not a condition. These are the only two conditions, and so we call this as I discussed earlier. If there is any degeneracy, you will not satisfy this condition. So this we call as non-degenerate initial solution. Okay. So then we'll move to the actual method. So that is what I'll discuss. The first one is modified distribution method, or MODI method we call. This is also called as UV method. This we'll also find using, these are like jointed. We'll discuss what is this modified method, UV method. Okay. So once we get this solution using this initial value, a northwest corner, whatever, then we'll take that value and we'll check whether this is the optimal. So there will be a check before proceeding further. Then we see. So for that, let me take one example and see. So I'll take a simple example for this case. So let me note it as origin 1, origin 2, origin 3, and this is demand, and we have supply. I can remove this. Yeah. So we'll just, I'm writing the question. These are the destinations or demands D1, D2, D3, D4. Then I will write the values, and let me write the supply 250, 350, and 400. Similarly, we have these demands. You can check whether demand and supply are both are equal. Then we'll see the values, the cost values. Okay, this is the actual cost values. So just apply this least cost entry method. So you are supposed to get. Then we call this, basically we call this as a least balanced problem if supply and demand both are equal. So let us move forward with the least cost entry method in this case. So whichever is least we allocate. So I'm directly writing the values. So this is also one method of allocating. So initially, I wrote three these cost values in brackets, then the actual values inside the bracket. But this we can write like this so that the further steps will be easier for us. So whatever I'm writing in red color are the like allocations, and the green colors are the you know the cost values. You can write any side. There is no. So this is the allocation using this least cost entry method. And then the total cost, if you do, you are supposed to get 3700. Okay, this you can take directly, no need to do right now. So this is the actual value, and then we see how this UV method can be applied for this. Okay, so for this case, for this UV method, so generally we'll have this U1 V values. Okay, and we need to find this for all the rows and columns with respect to this allocated cells, and then we'll see what exactly happens then next. So now I'll further I'll not take any values. I'll directly take this. So this whatever you want EV values, it is nothing but the unit cost per certain factory to the destination center. Okay. Okay. Now I'll not write everything. I'll just write the whatever I need. So that is nothing but 317426598332. So this is the values. So now I know what are the values that are allocated. That is nothing but 3 is allocated, 1 is allocated. Means what are the cells that are allocated? 6, 5, 2, 3. So these are the allocated cells. So so according to these allocated cells only, I will calculate this U values. So on vertical column you will write U1, U2, U3. On horizontal we will write V1, V2, V3 and V4. Now for initial solution, we allocate this U1 to be 0. Okay, and we proceed with this. So if you and you have to calculate these values according to the allocation only. So this is and this only allocated from those two we will get V1 and V2, and from this we will get V3 accordingly. So if U1 is equal to 0, we have a relation like U1 plus V1 is equal to 3. So from which you will get V1 as 3. Okay, so then we have the other solution, that is U1 plus V2 is equal to 1, which implies 1. Okay, so then V2 we got V2 values. So we also have U2 plus V2 is 6. That implies U2 is equal to 5. Okay, so I'm just going a cyclic. So initially I got this V1, then I using V1 I found V2. So using V2 I found U2. Okay, similarly I'm coming calculating all these values. Then U2 plus V3 is 5. That implies V3 is equal to -2. Sorry, U2 plus V3 is 5 and U2 is 5. So V3 value will be 0 since both are 5. Then we got V3 value. Then using V3 I can easily calculate U3. Okay, so using U3, that implies V4 is nothing but -1. So this is the way you calculate these UV values. Okay, so now once we got these values, we calculate these cost values. Sorry, not cost values. We can call penalty values for all these allocated cells only. So that is penalty P is equal to UI plus Vj minus Cij. Okay, I will explain. So if you see in the first row we have two unallocated. I'll mark with this yellow color. We have two unallocated. Then here we have two more, and we have two more. So in each row we have two more, two more, two more. So we just calculate the penalty values of these cells. Okay. So let me calculate for C13 first row third column. What we have first row third column, U1 plus V3 minus C13. That is U1 is 0 and V3 is also 0. And what is C13? 7. So we get minus 7. Okay. So similarly, if you calculate for the other rest values, rest of values, minus 5. Okay. So if you do this, all those values, I am writing directly P14. So we have to calculate P21. Similarly, P24. Then what else? P31 and finally P32. So if you find these values, you are supposed to get 6 minus 5 minus 2 minus 1. So now if you see the penalty values are minus 7 minus 5 and we have 6 and minus 5 minus 2 minus 1. So now I'll write the rule. So the rule is if the value that you found using this initial solution is optimal or not, if let me write, if all penalties are 0 or negative, then the answer is optimal. Okay. But if you get any positive value, it means it's not optimal. We need to re-verify it. Okay. So that is the procedure. So luckily we have only one, that is P21. So there might be any also. So we only got 6, this P21, that is nothing but second row first column, that is this one. Okay, that only we got, but we can get more number of this positive values also. So in that case we need to move to the next step. So that is select the maximum penalty. Of course you select the positive value only. So in this case we have 6 as you saw. So this is the maximum. Okay, so once you get this maximum penalty, so we call that cell as basic cell. Okay, so now we need to include this solution. We include this cell in the solution. So by simple method, I'll explain here. So now we again go back to the initial solution, that is So we got 3174, then 2659, and then 8332. Okay, now we selected this as the basic cell 2, which is having the maximum positive penalty. Okay, and then I will also write what are the quantities that is allocated. So in this we have 200, in this we have 50, here I have 250. Okay, this is the method. So once you got this, so now you need to construct a closed loop among this. Okay, which this closed loop, right, closed loop. But how to construct this closed loop? It should contain only the allocated cells. Okay, so for example, so from here I have to go construct a closed loop. So I can go like this. This is one, or I can go in the from top side also. So we have two paths. But the second rule says you should go only through allocation cells only. So in this case, I have to go like this, like this, like this, and like this. So because I need to pass only through this allocated cells. So the other route that I said is not the correct value. So now we allocate these values. So we start positive here, negative, positive, negative. So this alternative positive negative we allocate. We start the initial basic cell with positive value. Then we see whichever is the you know smaller in these negative values. So so we have negative cells in the first column and second row second column, but we have minus 200 and minus 250. We should select the minimum of these two, like maximum of these two, because there is a negative sign. So I'll select minus 200. Okay, so either, because there is a negative I said maximum, but in general you just see these values, you just select because they are positive, you should be minimum of 200 and 250. Nothing but 200 is a minimum, and you just according to the symbol you just place inside that. So because that is nothing but, so we have minus here, so minus 200 it is already there, so we'll just subtract 200. Here 50 we have plus, so we'll add 200 here, and we have 250 we have minus, so we just subtract 200, and 2 we have only 0, so we'll add 200. So the new system will look like, okay, so 200, so we will get 250 here, then 250 minus 200, 50 here, and then 200 here. Okay, this is how we modify the solution if we get maximum penalty value. And again we do the same procedure whatever you did here, calculating UV values, then calculating the penalties. Okay, then we'll see which if the solution having this, we'll calculate the penalties. If penalties are zeros or negative, then that is the optimal, you reach the optimal solution. Suppose they are positive, we'll select the maximum positive value, remember the maximum positive value, and then we repeat again. Okay, this is how you find the optimal solution method using this modified distribution or UV method. Okay. Any doubts in this? If not, we can call it a day. So you can proceed with this. So now I will write the initial solution. So it is a little interesting as well. So now you got this. Now the next step is calculating UV values. Okay, we'll equate this U1 to 0. Then we calculate V1. That nothing but 3. Sorry, we cannot calculate V3 directly because it is not allocated as in the previous solution. So we will directly go to V2. V2 is 1. Okay, then we see so when U2 V2 uh, then if V2 is equal to 1, U2 plus V2 is 6. So this will be 5. Okay, if this is 5, then V1 should be minus 3. Then only you will get U2 plus V1, you get 2. Okay, and as well U2 plus V3 is 5. So V3 is always 0 again. So once V3 is 0, U3 you will get as 3. If V3 is 3, and then U2 will get minus 1. Okay, and you calculate the penalties again. That is nothing but U plus V minus C. And see if the penalties are positive or sorry 0 or negative, then that is the optimal solution. If they are positive, then you repeat again. So if you see, if you try to do this in one more time, I will give the solution answer, then you can verify this with. So, so once you calculate penalties, that there will be one more. There is a positive value 1. Then you will modify again. Then you will reach an optimal solution, and the optimal value is 2450. So this is the optimal, the total optimal cost for this. Okay. So and then what is the initial cost? 3700. So that is the initial cost or feasible cost, but optimal cost is 2450. After 2 more iterations you will get this 2450. Okay, so that's all for today. Yeah, we are that is we are done for today. So if you have any doubts, you can ask, that we can close the session. And thanks for attending. Yeah, thank you.